Hello, so in this video we'll continue our discussion about the planes. So as a revision, what did we say about the definition? So if we have P1 and P2 are some distinct points, then a collection of all points for which this vector from P1 to P2 is orthogonal to P1 to all those points here, they constitute a plane which is gamma. So the equation of this is given by the dot product of P1 P2. So P1 P2 is this vector A1 A2 A3, and P1 P is x minus x1 because our P is x y z, and our P1 is x1 y1 z1, and our P2 is x1 plus a x2 plus a1 a2 and x3 plus a3. Okay, so these are the coordinates of these 3 points. So this is the vector on the plane. Okay, and this is the vector normal to the plane. So this is also, sometimes this is also known as the normal vector. Okay, so now as some other applications of the planes, we are interested in finding the distance from a point to the plane which is given by this. Okay, so now let's see, this is our plane here, this gray part. Okay, so and this is my point here. So let's say this R is some point, so this R is on the plane we are interested in. Okay, and then the distance from R, the vector from R to P is our this P vector. Okay, now note that from the diagram, and then this n is the normal vector. So note that from the diagram, if we take the component of this P along the direction of n in the same line, so then what we are interested in, this from distance from this point to this point. So this is the shortest distance, right? So when we say distance, it means shortest distance. Okay, so if we take the component of P along the direction of n, we will get, and then take the magnitude of that, then we will get our distance from a point to the plane. Okay, so if we do this operation here, so what is our R? So let's say R is x1 y1 z1. Okay, then my P is, so this means my P is my P is minus 6 minus x1, because P is this 2 minus y1 and 3 minus z1, and then this should be in this kind of enclosures. Okay, so this is my P. What is my N? N is from here. So N is, we have already seen that these coefficients, they correspond to the normal vector. So 4 minus 5 and 8. Okay, so now this and this, so we have to say the component of, so component of P in the direction of n, and then we have to take the magnitude of that. So what is the formula? So we'll see P dot product of P and the unit vector, correct? So I can also say I can also take the magnitude of this unit vector outside and say P dot n. Okay, so what is the magnitude? So I can say here this is equal to 4 squared plus negative 5 squared plus 8 squared here. So this means this is equal to square root of this is 16, this is 25, and this is 64. So this is 105. Okay, so I can say 1 over root 105, and then here I have to say this and dot product with this. So I have to say 4 times minus 6 minus x1 minus 5 times 2 minus y1 plus 8 times 3 minus z1, correct? And then so then this is now different from this, so let me put a separator here. Okay, So then I have to say 1 over root 105. This is just algebra now, but there is one small thing which we have to take care of. So this is minus 24, this is minus 20, this is plus 24, this is minus 10, sorry, and this is plus 24. Okay, and then I have to say minus 4x1 plus 5y1 minus 8z1. Correct? Okay, now since this x1 y1 z1 is on the plane, so this means this equation is satisfied. So if I say minus 4x1 plus 5y1 plus 8z1, so then let me put it here. So I can say minus 4x1 plus 5y1 minus 8z1 is equal to what? So then from here, if I have 4x minus 5y plus 8z minus 7 is equal to 0, and I can bring all of them on this side. So this means negative 7, this is equal to minus 4x plus 5y plus minus 8z. Okay, so let me erase this minus here. Okay, minus 8z. So then since x1 and y1 and z1 are there, so I can repeat this, remove this, and replace this xyz by x1 y1 z1. So this guy is equal to minus 7, so I can put minus 7 here. So my answer is, so then this guy here is 1 over root 105 minus 24 minus 10 plus 24 minus 7. Okay, so this is equal to minus 17. Okay, so then the height is, since we have to take the, actually we have to take the magnitude here. So then this means h, this is equal to minus 17 over root 105 magnitude, which is equal to 17 over root 105. Okay, so this is how we find the, I mean, after this there is only one small thing which we have to take care of, that we have to find, we have to use that this x1 y1 z1 are on the plane, so that is why this can be replaced by an actual number. Okay, rest is all simple algebra here. And always remember that whenever you have to find the distance from the point, from the plane, you have to use this formula. So you have to take the normal vector and some vector p from the point to a point on the plane, and take the dot product of take the component of that vector in the direction of the normal vector. Okay, okay, now we are interested in shortest distance between two skew lines. So what are skew lines? So skew lines we have already seen. The skew lines are those who do not intersect and are not parallel. Okay, okay, so let's say we have a line L1 which has 2 points A and B. Okay, and we have another line L2 which has 2 points C and D. Okay, so let's assume this A is 1, minus 2 and 3, this B is 2, 0, 5, and this C is 4, 1, minus 1, and this D is minus 2, 3 and 4. Okay, okay, so my first job is to find a vector. So find a vector on both lines, on L1 and L2. Okay, so I can say find a vector on L1 and L2. So when we have AB, this is equal to 2 minus 1 is 1, 0 minus negative 2 is 2, and 5 minus 3 is 2. Okay, and then CD, this is equal to minus 2 minus 4 is minus 6, 3 minus 1 is 2, 4 minus negative 1 is 5. Correct? Okay, Now my next job is find AB cross CD. Why do we do that? We do that because it will be normal to both L1 and L2. Okay, so let's do that. So then this AB cross CD, this is equal to I J K 1 2 2 minus 6 2 and 5. Okay, so this is equal to I. So with I have what? 10 minus 4, which is 6, minus J. So for J I have 5 minus 12, which is 17, plus K, which is 2 minus 12, which is 14. Okay, so I can say here 6 minus 7 and 14. Okay, so this is a normal vector from L1 and L2. Okay, now note that a plane through A and let's say this guy, I call it N, and a normal vector N, consider another plane through C and normal vector N. So this plane, these two planes will be parallel. Why? Because their normal vector is the same and they pass through different points. Okay, so this plane, so parallel, they are is parallel to. Okay, do you agree? Because the normal vectors are the same and they have different points, so therefore they should be parallel. Okay, and then it's also easy. So let's say this is my plane P1 and this is my plane not P1. Let's say this is my plane gamma 1 and this is my plane gamma 2. Okay, now also, do you agree that gamma 1 contains L1 and gamma 2 contains L2? Why? Because this vector n is also orthogonal to L1 and it is also orthogonal to L2, and this is also orthogonal to this whole plane, and this is also orthogonal to this whole plane. So that's why this line should be contained in this plane. Okay, now the next step is, so now we are interested in, okay, so then the shortest distance, so I'll say shortest distance between L1 and L2 is the distance between the and gamma 2 and is the distance between gamma 1 and gamma 2 along the normal vector n. Okay, so how do we find it? We find distance between our gamma 1 and gamma 2 is what? So we are interested in AC, so we will say, so we are interested in AC, so we will say component along n of AC, because A is our point on gamma 1 and C is our point on gamma 2. Okay, so then this is equal to component along n of, so what is AC? So AC is, if we go a little bit up, AC is 4 minus 1 is 3, 1 minus 2 is again 3, minus 1 minus 3 is negative 4. Okay, so then all we have to do is, so this is equal to, what is our n? N is our this guy, which is 6 minus 17, 14, dot product of 3, 3 minus 4 divided by the magnitude of n, which is 6 squared plus 17 squared plus 14 squared. Okay, so then this is equal to 6 times 3 is 18, minus 17 times 3 is minus 51, and 14 times minus 4 is minus 56, and then of course we have to take the magnitude here. So divided by 6 squared is 36, 17 squared is 289, 14 squared is 196. Okay, and then of course we have to do this. Okay, so if we do that, we will get our answer as around 3.9. okay, units. Okay, so again, what do we do is, if we have to find the distance between two skew lines, we find the normal vector by taking the cross product. That is the normal vector between the planes which contain one of the points here, and you don't have to take A and C, you can take B and D as well. Okay, and you can check whether you get the same answer or not. Okay, so the point here is that first of all we have to find the normal vector between those two lines by finding a vector on those lines, and then a plane through one line, and the same normal vector should be parallel to the plane through another line or another point. Sorry, plane through one point in one the normal vector should be parallel to the plane through another point on the second line and the same normal vector. Okay, so this is important here. Okay, so once you have established that they are parallel, then all you have to do is you have to find the distance between the distance between those two planes, and that has to be calculated by the taking component of, you make a vector. So for example, this is my AB, so this is my AB, and this is my CD, let's say. So then this vector here, this vector, or you can say other way around. So this vector, its component on, let's say this is my plane here, this is my plane here. This is a bad drawing, but what I'm trying to say is that you have to take the component of this along the normal vector. Okay, so this is, if this is my n. Okay, so then the component of this vector along the normal vector is giving me what? Is giving me the distance between those two parallel planes, which in turn is the distance between, shortest distance between the two lines. Okay, so this is it about finding the distance. So in short, what we have done is we have done two things today. We have found the distance. We have found the way to find a distance between a point to a plane, and we have worked on finding the shortest distance between two skew lines using this plane approach. Okay, hope it was easy to understand, and thanks for watching. Hope you liked the video.